This lecture is on dimensional analysis. This is something that we are going to be using throughout the year, so it's very important for you to be able to perform dimensional analysis problems. This does involve some math, or all math, so make sure that you do have your calculator with you as you go through this lecture and as you are going through practice problems. So what is dimensional analysis? Dimensional analysis is when we convert from one unit of measurement to another. Now, you've already done this when you did metric conversions. So you're going from grams to kilograms or meters to millimeters. And what you were doing is simply moving the decimal place. But this is when we're converting things like feet to meters, where it doesn't go by decimal points. So what we have to use are these things called equivalent statements. So an equivalent statement is a relationship between two measurements of equal value. Equal value. Now, what does this mean? An example of an equivalent statement will help. It's something like that 1 inch equals 2.54 centimeters. Because we cannot convert directly from inches to centimeters by moving a decimal, we have to use an equivalent statement. So if I were to measure something that was an inch long, if I used a centimeter ruler, I would measure that it was 2.5 centimeters or 54 centimeters. These are the exact same measurement, but they just have a different unit. So one is in inches and one is in centimeters. So you're going to become very familiar with these equivalent statements. I will give you a sheet with them. The worksheet that you have right now does have quite a few equivalent statements on the top, and that should get you through most of them. Sometimes you will receive equivalent statements in a problem. You do not need to memorize these numbers. These are things that will be provided for you. One of the keys of dimensional analysis is to remember that units matter. And we have to write them out, and we have to keep track of them. A lot of people try and skip steps. A lot of people try to not write out units. And there are going to be times where you can do these problems very quickly and very simply without writing the units out. But you need to get in the habit of doing this now, because as we get into more stuff that you're not as familiar with the units, it's going to become very important for you to write the units every single time. So do not write a number down without having a unit with it. So two things that you need to remember, and this will make more sense as well when we start doing some practice problems, but you multiply numbers that are on the top of a ratio and you divide numbers that are on the bottom. So right now I have a problem for you down here. Does not have any units on it because all we're looking at is the numbers and what we do with them. So I want to kind of show you what the math in one of these problems is going to look like. So you're going to multiply the numbers on the top. You're going to divide on the bottom. So you're going to see setups that are very similar to what you are seeing down here with the 25, 10, 15, 1/2. What you have to remember is that this is just like having this number in parentheses. So you multiply the top, divide by the bottom. So the first thing that I'm going to punch into my calculator is 25 times 10, because those numbers are on the top. So 25 times 10, do this problem with me as you're going in your calculator. 25 times 10 is going to give us 250. But I also have a number on the bottom. That's a 1. Whenever you divide by 1, you get the same number. So essentially I am dividing by 1. Really no reason for us to put that in our calculator because we know what that's going to give us. Still at 250. And then we move on to our next set. So we've done this. Our next set is 15. So we multiply by 15, which should give you 3,750. Dividing by 1, we're still going to have that same number. So now we've done this one. Now we move on to our last parenthesis set here. Multiply by the top. We're multiplying by 1, still going to have our same number. And then we divide by 2, which should give you 1875. So the easiest way to do this is think of each statement as its own math problem. And you need to remember that you multiply on the top and you're going to divide by numbers on the bottom. So you may see a question like this: how many hours are in 2 days? I have no doubt that all of you can tell me this answer without doing any sort of math on paper. But we know this because of an equivalent statement. And that equivalent statement is that 1 day, we know, equals 24 hours. So what do? You're going to multiply the 2 days by the 24 hours to get 48 hours. But why does this math work? So that's really what we're going to look at here. So this is a very simple dimensional analysis problem, but I want to go through it so you see where the units are and where they come from. So the key with a dimensional analysis problem is to start with what you are given in the problem. We are given that we have 2 days. So I'm going to start by writing out that we have 2 days. And now what we're going to do is we're going to use this equivalent statement that we already know in our heads to get our unit into hours. We want to be left with a unit of hours, which means that we need to get rid of days. Now, if you remember back to the density video that you watched and when you did those problems, if a unit is on the top and a unit is on the bottom, they cancel. So we want days to cancel. So what we do is days is on the top on this side over here, the 2 days. We need days to be on the bottom. So we're going to rearrange our equivalent statement. So days is on the bottom and hours is on top. So now what happens? Our unit of days is going to cancel, and we are going to be left in a unit of hours, which is what we want because that's what's in the problem. So now if you go back to the slide we just did, we multiply numbers on top and we divide by numbers on the bottom. So we're left with 2 times 24, which is 48, divided by 1 equals 48, and the unit we are left with is hours. So a pretty easy problem for us to do here. So let's go on to something that's going to be a little bit more difficult. Your house is 5.4 miles from school. How many meters is this? Now, we can't do this by just moving the decimal. We have to use equivalent statements. So it would be a good idea right now to have out either an equivalent sheet that I have given you if you've gotten one of those already, or your dimensional analysis homework that's in your packet, because that will also have some equivalent statements as well. I will provide them for you in this video though. So first thing is, take a look at what you have. We know that we're at 5.4 miles, and what we want to our unit to be in at the end is meters. So we're trying to go from miles to meters. Now, there will be plenty of times where you can find a conversion from one number to the other, but then there's also going to be a lot of times where you're going to have to do multiple steps. This is one that we're going to do a few steps in, just so you can see how this actually works. So, we are going to start with what we have. We have 5.4 miles. And we want to get to meters. Now, if I'm looking at my equivalence sheet, it depends which one you're looking at. I know that 1 mile equals 1.609 kilometers. Now, I don't want to be in kilometers, I want to be in meters, but we know from converting metrics that I can easily go from kilometers to meters. So this would be a good path for us to go on. Now, in order for the unit of miles to cancel, I need them to be on opposite sides of the line. So miles is on top here, which means that I need my mile equivalence number to go on the bottom, 1 mile, which means that my 1.609 kilometers is going to go on top. So I'm going to erase this one because we don't need this equivalence statement anymore. Now, my suggestion on this is set up your entire problem before you start doing any math. Okay? So now we know that we're going to see that we canceled miles, so now we're in kilometers. So now we have to convert kilometers to meters. Once you start getting the use of metrics, you're going to realize I don't always have to just count my decimals, because what you're going to know is that 1 kilometer is equal to 1,000 meters. So remember, if we had a decimal point here for 1 kilometer, if I move it 1, 2, 3 spaces to get to meters, that's the same as 1,000 meters. Some of these you're going to be so used to by the end that you're not even going to have to move that decimal. So I want to get rid of my unit of kilometers, which means if it's on top here, it needs to be on the bottom here, which means 1,000 meters goes on the top. So now my kilometers unit cancels, and I am left with meters, which if you look back in the problem, that's what we want. And I wrote 100 there, make sure it's 1,000, all right? So now we're going to do the math. Multiply the top, divide by the bottom. So if we have, and you do not have to do this in multiple steps, you can just keep typing your numbers in. So we have 5.4, and we're going to multiply that by 1.609. We would divide by 1, but we know that's going to give us the same answer. And now we're on to this equivalence statement here. We're going to multiply by 1,000. We're again going to divide by 1, and we are left with, you should get 8,688.6 meters. Make sure you're doing the math with me as you go, okay? Because I don't want you just to trust that this is what it is, because I want you to get practice calculating this or putting it in your calculator as well. All right, so let's go on to another problem. A person weighs 154 pounds. We want to convert this to kilograms. So again, what unit do I start with? I'm starting with pounds. I want to go to kilograms. So not something I can just move the decimal on. I need one of those equivalent statements, and that is given to you in the problem. Sometimes you will see these given to you. So I start with what I'm given. I'm given 154 pounds, so that's my abbreviation for pounds. And I'm going to use the statement that's given to me in the problem. 1 pound equals 454 grams, so pounds is on the top. To get that to cancel, it's going to go on the bottom, 454 grams. Pounds cancel. My units are grams, but I want kilograms. So 1 kilogram equals 1,000 grams. That's the same thing as you saw before with 1 meter and 1,000, or 1 kilometer and 1,000 meters. Same thing, we're just moving the decimal point 3 spaces. Grams is on the top here, which means that grams needs to be on the bottom. We haven't seen a problem like this yet, where we have a number on the bottom. So most of them have just been a 1 on the bottom, but now we have a 1,000. This is fine, okay? I see a lot of people try and make sure that there's always a 1 on the bottom and the other side of the equivalent statement that has the other number is on the top. It does not matter. Your value can be on the top, your value can be on the bottom, the 1 can be on the top, the 1 can be on the bottom. That is just going to depend if you multiply or divide. So it has There's no need to try and rearrange things so your value other than 1 is on the top. All right, so now our grams cancel, and we are left with kilograms, which is what we want from the problem. So now we're ready to do our math. So numbers on the top, we have 154, and we're going to multiply that by 454. Then we're going to divide that by 1, which leaves it the same. Now we multiply by 1 on the top. That leaves it the same because we're here now. And then we're going to divide by 1,000 because that is on the bottom. And we should get, erase this statement down here, 69.916 units are kilograms. Now, what is this telling me? It's telling me that 154 pounds that we started with is the same thing as 69.916 kilograms. Sometimes we need things to be in different units, and the way that we do that is through dimensional analysis. So we're going to do one more problem here, and this is one that tends to be the most complicated, but if you remember to write out your units, make sure they cancel, you will be just fine. Your car is moving 70 mph, so miles per hour. How many meters per second is this? All right, so now we don't just have one unit, we have 2 that we're trying to convert. We're trying to go from miles per hour to meters per second. Anytime you hear per, that means that you have a ratio. So miles per hour is miles over hours. Meters per second is, and I wrote it that way up here, is meters over seconds. So you're going to see a lot of problems like this that are rates. The rate something is moving. It's moving at a rate of 70 miles per hour. It's moving at a rate of 15 feet per second. Whenever you see that per, you need to have 2 units on that. One goes on the top of your ratio, one goes on the bottom. So it's very important for you to remember those. It's going to make doing these types of problems a lot easier and making sure that you're using those units. So we're trying to go from miles per hour to meters per second. We start out with 70, so we're going to write that down, and that's 70 miles per 1 hour, okay? So per hour is implying that it's in a single hour you would be going 70 miles. Now, we need to convert miles. We're trying to get miles into meters, and we're trying to get hours into seconds. So we have 2 sets of units to convert here. The easiest way for you to do this is convert one of them at a time. Do not try and convert miles to meters and hours to second at the exact same time. Let's do them each separately. So let's go from miles to meters first. We're going to use that same equivalence statement we used a few slides ago with the 1.609 kilometers equals 1 mile. So we have 1 mile is 1.609 kilometers. So now our miles cancel, we're left in kilometers, and we're going to convert that into our meters. So 1 kilometer, 1,000 meters. So remember, on the top and on the bottom, they need to be canceled. So if I were to stop right now and calculate this, my unit of rate would be meters per hour. So see how you read the units, meters per hour, because I haven't done anything with the hours yet. But we want to be in meters per second, so now we have to convert hours into seconds. There's a few ways you can do this. We're going to do one that you're pretty familiar with here. we know that we can go from hours to minutes and minutes to seconds. So for hours to cancel, hours is on the bottom here, which means that hours needs to be on the top. We all know this equivalent statement. 1 hour equals 60 minutes. So 1 hour, and then my 60 minutes is going to go on the bottom, which means, and I'm going to do this in a different color so we can see how our units are separate. Hours are going to cancel. So now, if I were to stop here, I would be left with meters per minute. But not quite there. We need to go to meters per second. We also know that 1 minute equals 60 seconds. I need minutes to cancel, which means that minutes in my equivalent statement needs to be on top. 1 minute equals 60 seconds. So minutes are now going to cancel, and I'm going to be left with meters per second. And what do I want in the problem? I want meters per second. Now comes the part where we have to do the math. Now, you've already set up the equation, so now you can do everything at the same time. So we start here, 70 divided by 1. We know what that is. So we are done with this part of the statement. So I'm going to color them out as we go. We've done that one. Now we're going to multiply by the top. 70 times 1.609. And now we know that we divide by 1. Okay, stays the same. So we're done with this one. Now our value is on top with this one right here. We're going to multiply by 1,000. Divide by 1, stays the same. And now we get to this one. We multiply by 1 because it's on top. And now we divide by 60, which is on the bottom. And now we're done with this one. Now we get to this last equivalent statement here. 1 is on the top, so we're going to multiply by 1, stays the same. Once again, divide by what's on the bottom, which gives me 60. So we should get, let me check the math here, 32.29. Let me do that one more time just to make sure. 70 times 1. Nope. Did something wrong, punched in the calculator wrong. 31.29. 31.29. And my units are, you got to go back in our problem here. I know there's a lot going on. It's highlighted for us, meters per second. So, a lot of stuff going on here, but what you have to remember is if you can keep track of your units and if you can make sure that your units cancel, you will be just fine. Plenty of practice problems for you to do. Go ahead and try them. Some are easier than others. Don't get frustrated if one is hard. Move on to the next one and see if you can do that one as well. Try and do the easy ones first, and then once you get some practice, those harder ones will definitely help you out. So if there's one thing I can tell you that you need to make sure that you are doing every time, and you're going to get so sick of hearing me say this, units, 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 units. Do not forget to include those. All right, so good luck working on those problems, and come see me if you need any help.